Robots perform many underwater tasks which are impossible or too risky for scuba divers to carry out, like collecting samples from the ocean floor for scientific research, exploring shipwrecks, inspecting underwater pipelines, searching for planted explosives, or recovering bodies. This particular underwater robot is designed to find unconscious drowning victims. Recent incidents have shown that a person recovered within 90 minutes can survive without brain damage when rescuers follow a specific resuscitation protocol. The robot uses a protruding interlocking jaw to grab the victim by a limb and haul him or her to the surface. Its onboard camera gives operators at the surface an underwater view. When the water's too murky to see anything, video-enhancing technology and imaging sonar detect the outline of objects. Several thrusters propel the robot through the water. For each one, technicians grease, then position a pair of O-rings onto end caps, which they install on each end of the thruster housing. The O-rings seal the end caps, keeping water out of the motor located inside the housing. The motor's shaft protrudes through the propeller end cap. A mechanical bail secures both thruster end caps to the housing. They fill the thruster with oil. This prevents the thruster from imploding under pressure as the robot descends deeper and deeper. After filling, they draw a vacuum to remove any air bubbles and draw the oil into every nook and cranny. Then they install a reservoir, which they also fill with oil. When the underwater pressure builds, this backup oil supply fills any remaining minuscule air gap the vacuum might have missed. They close the reservoir with a sealing screw to prevent any oil from leaking out. Now they turn their attention to the thruster's main component, a two-blade propeller made of durable nylon. It goes on the back end of the thrusters. They install the camera chassis onto the robot. This chassis also carries the majority of the robot's electronics, such as the computer, communications equipment, and lighting. Here, they're hooking up the belt for the tiny motor, which tilts the camera to look up and down. They cover the camera chassis with a transparent acrylic dome called the viewing port. A cap with an O-ring seal keeps water out. They install the robot's power supply at the opposite end of the robot, then encase it in a metal tube, sealed on both sides with an end cap and O-ring. For the thrusters to work at maximum efficiency, the robot must be neutrally buoyant, meaning neither too light nor too heavy. So once the robot is fitted with all its thrusters and electronics, technicians install the main float. Certain models have additional floats. They cap each propeller with a vented cover called a quart nozzle. This isolates the water flow, maximizing the propeller's efficiency. These bumper frames act like the bumpers on a car. They absorb the force of impact, protecting the robot from damage when it encounters underwater objects. The bumper frames also serve as a structure to attach lights and other components, as well as specialized tools, such as that quick-release jaw, which grabs the victim by a limb. They install the jaw at an angle so that it doesn't block the camera's view. Now the sonar unit. It also mounts to the bumper frames. The sonar projects a 130-degree left-to-right 3D image onto a monitor at the surface, showing the outline of objects around the robot. Finally, at the top, they install a strobe light, a flashing beacon which tells rescuers on the surface exactly where the robot is. Every underwater robot goes out for a test drive. They submerge it in a tank, which is essentially an aquarium inhabited by fish of the stick-on variety. These inanimate creatures adhere to the glass, provide colorful images on which testers can focus and unfocus the camera. From there on in, the first mission in open water awaits.